Hi and welcome to Geeks for Geeks. Today we would be discussing the problem bleak numbers. So now this problem is a observation as well as this problem is a problem which would tell you at what instance you need an observation for an online judge. So now let's understand the problem. So the definition of bleak numbers is a bleak number is a number which can't be represented as the number and the count set bits of x. What I meant to say is, let's say we have a number 4. Okay, so can we represent 4? Can we have the value 4? About how? Like let's say this is 1 and in binary representation of 1 is what? 1. So the number of set bits. What does the number of set bits? Set bit just means the number of one digit in the binary representation. That is also 1 and this value is equals to 2, which is not equal to 4. Then we move forward to 2. Then 2 plus what is the binary representation of 2? It is 1 0. Again the number of set bit is 1. So the value is 3. Okay. Then we have 3. The number of set bits is 2. Okay. So it is equal to 5. Okay. Now let's go to 4 also. 4 and the number of set bits of this is equal to 1. Okay. Which is equals to 5. And then we go to 5, let's say. 5 plus what is the set bits? Number of set bit is 2. It is equals to 7. Now, this number is not a bleak number, okay, and there is no point in moving forward. Okay, why? Because there is a component of x and y and I want it to be equal to a value, let's say z. Then this x should be less than z if let's say a plus b is equals to c. At any instance, if a becomes greater than c, then by no means a plus b would be equal to c. Okay, by no means we would have it. That is why whenever we reach the point of this value, we can stop at that instance only. We don't really need to go further. This is the very first observation, that a component of x and y. What is the component? X is the number itself. X is the number itself. And y is the set bit, okay, set bit of x. And x plus y, I want it to be equal to the given number, that is n. So if x is only greater than n, then there is no point in moving forward. So we should move till the point where x is less than equal to n. Okay. Why less than equal to, not equal to? Because apart from 0, every number would have at least one set bit. That is why we should move till the point of x less than n to be on the safer side. Okay. Now, this is the first observation, that x should be less than n itself. So now we can simply iterate from 1 till the value of less than n and we can simply solve the value. Okay. But there are two things to notice. So if you are a beginner, notice that the expected time complexity is less than what you are doing. This is the very first observation. If you are an intermediate, then notice that the value of n can be till 10 to the power 9. Okay. So to iterate on each of the values and do at least one observation, like you would be iterating from 1 till the value of 10 to the power 9 minus 1 approx. So you would be doing 10 to the power 9 operation, which is greater than 10 to the power 8. So you would be definitely getting a TLE if you do this linear approach of moving from 1 till the value of n. Okay, because in 1 second we can perform at max 10 to the power 8 observation. So there are two ways you can find the need of optimization in an online judge. Okay, so we need to optimize over this. So let's draw some more observations to this. Okay, the very simple idea of this would be that we would iterate from 1 till the value of less than n, and we would simply count the bits. Okay, so the very next observation, what is the next? We would talk about counting the set bits explicitly, but let's first talk about what can be the optimization. See, the value of n can range from 1 till the value of 10 to the power 9. How would I know? From the constraints. Okay, the value of x would also go from 1 till 10 to the power 9. To be honest, 10 to the power 9 minus 1, but we can take a rough value. 1 won't affect the answer that much. Okay, so if let's say this is x, and this would be the count of set bits of x, and this I want it to be equal to n. Count of set bits. Okay, so if the value is as big as 10 to the power 9, then how many bits we have? So if a value like 10 to the power as big as 9 we have, then the number of digits is 30. And if we make all the 30 bits, number of all the 30 digits as 1, then this value would at max be 30. Or to be on the safer side, this value would at max be 31 or 32. Basically, most of the time we take the value 32 to be on the safer side. Okay, so this value at max can be 32 at max. The least can be 1 can be the minimum, and 32 can be the maximum. This is what I would expect. Okay, so now if you just observe that, let's say this is x and this is 32, and I want it to be equal to n. Okay, if this is the condition, then the minimum value would be 1 and the maximum value would be 32, then we can say that the value would range, this x value would range from x n minus 32 n minus 32 to how much? To n minus 1. This is the solution. I don't understand it, Siddharth. Make me understand better. So let's say if this value is x and I have something like this. Like let's say the minimum value is 1 and the maximum value is 3. And this side I have 5. So the value of x, if this value is 1, then the value of x would be 4. If the value is 2, then x 5 minus 2 is equals to 3. If the value is 3, the value would at max be 2. What is 4? 4 is nothing but 5 minus 1, 5 minus 2, 5 minus 3. Here what was basically 5? This was n, this was x. So this is n minus 1. Instead of 5 I can write n minus 2 and n minus 3. So it would range from the n minus minimum value till the value of n minus maximum value. This is what I meant, that this value would range from minimum value to maximum value. This is what I meant. Okay, I hope you understand. So now we can just, to be on the safer side, we can just take the value of 32. If I want more optimization, suppose I am set, okay, we would talk about this small optimization in the end. So now the question is that we can simply iterate from n minus 32 till the value of n, and we can just check. But we need to count the number of set bits. How can we really do that? So counting the number of set bits is a subset of this problem. So our new problem is count set bits. This is our new problem that has encountered to us. So let's say the value is 1100. Let's say this value is something like this. So what we can do is, the idea is that we just left shift each time by 1 and do an AND with 1. Like suppose I want to count the number of set bits in this value. So I would do AND with 1 and this would result in 0. So I would have 0 in my result. Then I would simply do a right shift. Okay, if I do a right shift, this number would become something like this. Again, I would do AND with 1. This would result in 0, so I would add 0. Again, I would do a right shift. This would become something like this. I would do again an AND with 1, and this would result me with 1, 0 plus 1. Again, I would left shift and I would do an AND with 1, and this would also result in 1. Okay, and again I would do right shift by 1, which would result in 0. So total value is 2. 1 plus 1 is equals to 2, and adding zeros. This is how we would find the value of count of set bits. So each time we just do a right shift each time, and we do a AND with 1. Again right shift each time, we do an AND with 1 till we have some value. Like why we would have while loop. While n is equals to greater than 0, we would simply keep shifting it on the right hand side. So now let us implement this. So as I said, this is the function to count the number of set bits. While we have some value, we would simply do an AND with 1, and if it is true, we would simply increment it, else we would do right shift by 1, and else at the end we are inserting it. Now let's talk about the function that we need to solve. Now what we would do is int k is equals to 32 at this point. Now we would simply iterate from 1, I is equals to n minus k, and I is less than equal to n and I plus plus. At this point, if I plus count set bit of I, if it is equal to the value n, okay, I would return a false. Else, even after all of this, I am not able to return it, I would return it true. Now let us just compare and run and see how many errors are we making. Seems like no error is being made. And yes, we were able to solve. If this is an online judge, the number of operations are 32. It is less than 10 to the power 8. So we won't really have an issue over this. The number of operation is 32 multiplied by log of the values we are checking. So suppose if this question was given in an interview, then a little more optimization is asked from you. So what you can really do is, instead of taking the upper hand value each time, what you really can do is you can simply do a seal log base 2 and have a seal value of it to make it more optimized, and this would be more beneficial to you. So that's it. The time complexity is log n multiplied by log n. If you implement the interview approach, this is 32 multiplied by log n. Yes. So that's it for today. Thank you and have a nice day.